Hello everyone. So today's topic for me is non-containerized to containerized migration. So introduction for me, myself Surya Prakash Singh, and I work in NEC Technology India, and I've been working with the containers more than 1.5 years, and my overall experience in OpenStack is you can say cloud is around 4 years, and I have been working in the currently Kolla project as a code reviewer and developer, and contributing to the since multiple cycle. And other speakers with me has not been able to make it here just because of some of the issue with the visa. So I would be like to leading with the alone. It's all. So today's agenda, you can see right there. First, the evolution of the containers and the evolution of the containerized deployment. What are the advantages of the containers? Why we migrate like existing to the containers one? What are the exact use cases exactly for them? And why containerized with the Kolla? And feature, we can say it's like assumption for now to the migration with the Kolla, and some of the analytics you can say about the containerization from the existing cloud, that is the non-containerized one, and some of the some infra level migration feasibility we have to check first, so about them, and how do we containerize OpenStack with the the way of doing with the Kolla, and short demo may be there. So and next we have the question answer. So you can see right there evolution of the containers started it's not maybe the exact, maybe the even before that, but it's some of the data like in 1970 it's like a CH root system call got implemented for root directory of a process, changing the root directory of a process, and it's children to a new location in the file system. This actually advanced was the beginning to process isolation and segregation to the file process for each process. And CH root was actually added in 1982 to just the start of the Unix one, and comes to the FreeBSD gel with to achieve the clear-cut separation between its services and those of its customer to actually give the security and isolation to its administration. So the isolation and segregation also got here started with the FreeBSD gel, like security and edge of the administration with the container itself. And again, next one is like Linux vServer, where jail mechanism is used by the previous one, FreeBSD jail mechanism to where we can partition the resources like file system, network addresses, memory on a computer system. So this was the used by the FreeBSD itself, it uses. And next is the Oracle Solaris, where we the feature like snapshot and cloning of the images was implemented as a part of the kernel patch in the Linux. And next is the OpenVisit. OpenVisit is like patch kernel for the virtualization, isolation, and resource management in the for the some of the checkpoint in the container itself. And next is the process container. This is the started by the Google at to limiting the resources counting and isolation resources like CPU, memory disk, and networks for the collection of the process. And next is the LXC container. You already maybe it's like actual container implemented as a C group and namespace, which is the container property. to be used, to which actually containers we give for the OS level virtualization. And next is the Cloud Foundry. They also added, some of the isolated environment in the operating system itself, and they run as a daemon and provide an API for the container management. And again, let me contain that for you is adding and creating the like nested containers started here, but that was not that meaningful yet. So now the core and we can say the most adopted one comes into the picture, Docker one, and we already know very much about the current adoption of the Docker. And then container security comes it was like container booming from here, and so we have to take care of the security risk, and also that should be take care at that time itself. Container toolings come into picture, like one of the CNs, the Cloud Native Foundation Computing, adopted the Kubernetes, and and at the same time Docker and VMware, Azure, all give the support to the Kubernetes of the Docker or VMware. And next comes to the once again RKT container is adopted by the CNCF, and now we have the Kubernetes itself, like the more about the container application. So these are really the evolution of what you can see. And what are the advantages? I think everyone might be aware of the quite pretty much obvious one. Efficient CI we already have in the and compatibility, maintainability with the Docker container or the itself LXC we can also have. Simplicity and faster configuration like we do already in the Kolla and as well as Tripler project within the containers itself, and the Kolla image provide that for faster configuration, like we have the override mechanism. And rapid deployment, you see we frequently up and start the containers and stop the containers and redeploy the containers with it's quite fast. And we can have the multiple clouds with the use of the containers platform. And isolation is the one of the key things we see with the as a use case for the container, and the security is also one of the thing as we run the container as an isolated environment, so they run as an independent one. And we standardize, and version control is also can be used with the container itself. Now we can see the evolution of the containerized deployment. You can see that in the left side is all they were not using the containers for the OpenStack deployment. That was all about on the bare metal or on the OS or itself. So PackStack, DevStack, all have their own mechanism. That is, we can say, non-containerized one. Now the evolution is containerized deployment comes with the projects Kolla, Tripler, OpenStack, Ansible. And Helm itself is doing quite good this time. Kolla Kubernetes was also one of them, but couldn't make it shift. But that was also at one POC level good. So why migrate? Why migrate from the non-containerized to the containerized one? So here are the few use cases we can see. Like we have the load failure, then we can think about the migration. We need to maintain up the cloud, then sometime there might be some issue, so we need to migrate. Efficient resource usage, and we can see in the more elaboration all these quite fast. Yes, so node failure. A node failure, what can be the cases for the node failure? Like network issue, you can see we got out of the network, and storage failure, you can have the storage failure, disk failure in your cloud, so you need to migrate. Once you had checked point, like check that our storage has failed, so you need to migrate your VMs and all something. Heating issue in your data center, you can say natural disaster, then you need to migrate the maintenance of DC. Why we need the maintenance of data center? So sometimes we need to, upgrade our firmwares, we need to upgrade our hardwares, we need to, need some kernel upgrade for the, we very much we rely with the container, like container itself use the C group and namespace property. So sometimes we need to upgrade to the for supporting whatever we framework use for the containerization, like Docker, LXC, or it is. And efficient resource use, one of the useful use case here, you can see like we need to reduce the cost by, we can move over and to reduce the low network latency there. So we need to migrate the, VM closer to the storage net. And we can stack the more VMs on the single node to just, we can have the use of the free node, so we can reduce the cost here. And next is the resiliency improvement, that like suppose we have a noisy VM, it's consuming all the resources of the system, so we need to remove that VM. That can be also the case of the migration. So, and the next is the transfer of VM. We need to manage the workload on the node, so we can migrate to the next node. That is the real use case of the efficient resources. So why containerize with the Kolla? Kolla has its own use case, we have very good quick open stack deployment tool here with the Kolla with the high availability. You can already, I think many have experienced that if they have used the Kolla. And microservice architecture, one of the already container technology as Kolla use. So it's all microservice. So that's a good architecture to have in the deployment model. And easy upgrades we have in the Kolla. And like you just need to run the command Kolla Ansible upgrade and to the release whatever the next is. Different OpenStack releases in the single cloud, you can say. Like here we have quick OpenStack deployment with the Kolla and Kolla Ansible. We have two depots and deployment. Kolla is for the image purpose building, and Kolla Ansible is for the using those images and deploying to the appropriate nodes, and like controller nodes, compute node. We have the inventory file in the Kolla Ansible, so you can configure that. And we have very quick and fast deployment of the OpenStack. Like in once we have the image, it takes 20 and 50 minutes to run your cloud. This is one of the architecture of the Kolla itself. You can see Kolla uses the Docker and Ansible, one of the two technology stack here. And we write the Docker file and for the each and every service of the Kolla and OpenStack Kolla repo for the OpenStack services. And the same images is pushed to the Kolla image repository, and same is image has been deployed to the appropriate controller node, compute node, storage node, or whatever you have in the inventory file. Like we have the inventory file, the all-in-one, as well as multi-node in the Kolla Ansible. Easy upgrade, you can see you can easily upgrade from Okata, Pike, and Queens once you use the Kolla and Kolla Ansible. So that's quite useful for deployment too in the current. And easy development environment we can create. You see, we need to, sometime we face the creation of the development environment for the OpenStack services. If you want to contribute to any of the project, you can come to the Kolla and get the repo, and you can build the container for the development purpose for the respective services, Courier, Heat, Horizon. We have the support, and we are also in the progress and the queue in the to have more support for the development environment for the other services too. And this is the one of the very crucial one, you can say an important use case of the Kolla. Using Kolla, you can use the different OpenStack releases in the single cloud environment. So you have the one cloud, like you initially has the Okata there, and you were running the compute node, control node, and the storage node itself for the Okata release. But next you want to only upgrade to the really want to upgrade to the next release for the controller node. You want to only neutron run into the controller, then with the help of Kolla, you can restart your container and just use the upgrade to go to the next release with the help of Kolla. And same with the way we can do with the other services too for the queens or other releases. So here is the one of the analytics. You can see what we have to think before migration to the container, like from the non-containerized one. So code and what about the parameters like code, it can be an easy one if the process is single and we are migrating. And it would be quite difficult if the process like we need to migrate the multiple processes. And again, if it will be quite difficult, like we have the process self-modifying one, then that would be very difficult to migrate that time. But that can be possible, but you have to take care of all these things. And about the configuration file, it can be easy if it is only one file we need to configure, then just copy the configure file or reconfigure it. If you have the several files, then there might be some normal, difficulty level will increase. And if configuration file is anywhere like we have installed and somewhere has been placed, and we have to find that configuration file to migrate before migration to finding the appropriate configuration. And about the data, like before migration, you have to maybe stop node and copy the data. So if the data is placed at one place, then it will be more easier. And if the data is in the several places, so you have to copy from the several places and to the respective several places to the migration one. And if this data is anywhere in the file system, that also you have to find that first, then you have to have the appropriate mechanism to migrate that data for the migration. And network, like we have the application that we don't know that what network that application is using, so we have to check, like it can be HTTP, TCP, UDP. So for that, like it's only using the HTTP one, so we can it will be quite easier to move that application. If it is using like TCP, UDP, some data would be there in the data protocol. So IPsec would be quite difficult in that case. And installation, when we can consider installation is about what installer we have used for the installation of that application that we are going to move. So like we use the RPM or some script. So if we are use some script or package, then that will be quite easy. And if you use some RPM installer or some dev one, then we have to consider about the configuration first. And in case of the difficulty one, so we have the script, so we have to go according to the script you used for start that application or install that application first. And licensing is the one of the things. Before migrating to the container, you have to think about whether the application is open source, or you can migrate that application into the container or not. We have to check the proprietary one also and the restrictive. So that is also a case. Recoverability, you can see some applications are easy to recover, like we migrate and we can easily start that application. That would be much easier. And some of your application might get fail sometime very frequently. Then that case, the migration would be quite difficult. Like you have to consider the rollback functionality over there to support this. So this is the one of the checking the feasibility for the migration. We have the you can see the old infra like hardware and OS and Nova API, Sender API running on the OS, and we have installed, and we are going to move that to the container one, like Kolla container. So that if the possibility, yes, I have seen that this is the possible to move to the container. And performance, it will depend on the completely on the application. In general, in talk, like if you do not consider Nova API, then it will also depend on the application feasibility as well. And drawbacks also depends on the application, what kind of application you are migrating. And the same with the case 2, like we have the VM, then we install the Docker on that. It's kind of nested virtualization for the OS. But the same case is also possible, and we can see some performance, but also depends on the application what initially we are running and we are migrating. This is the little different one, like in the previous one you can see the only OS, and then we have the hypervisor at directly at the hardware, and we are virtualizing and VM is running. Then in that case, before migration, we also have to consider about the infra, what application application was running. So this is the one of the case. So in migration, we can see the possibility. Yes, this is possible. Again, the application dependent for the performance and drawback, we have to consider that. And the same with the case 2, like we have the Docker and OS, and it's also same. Like now we have the assumption with the migration with the Kolla. So what can be whether it is live or cold migration. So live is with the help of Kolla, like for now it's not in the scope. But cold migration I just have started with for the migration. In case of cold migration, like we have stopped the service, then we will copy and database and configure, and then we will start the containers. So second one would be the initial target for me. For now, maybe later I will check the feasibility. Then I will move further for my tooling. So what can be the possible step if we are going to migrate, like non-containerized. So containerized execution step with the Kolla, like stop node, copy the configured data, start container of the service, and roll back in case of if you are migrating and your migration get failed, then we have to roll back that. Here we can see the flow, like we have initially non-containerized cloud, you can say, and we have the multiple services you see, and now suppose we want to migrate to the Nova service to the container one with the help of Kolla. Then what can be the possible step here? So we already first we have to stop that service, or you can stop the node at itself to have the consistency in the data copying and configuring the Nova service. And we have Kolla and Kolla Ansible. So Kolla give the Docker images for your all the sub components of the Nova API and scheduler and compute. So once you have the images of the Nova API in the Docker Hub, you can pull that image. Once we trigger the migration with Kolla Migrator. So Kolla Migrator will be the new tool to migrate to your existing cloud to the container. So this is the initial flow you can see. So Kolla Migrator will pull that image, like Kolla Migrator itself will configure and check the version, what exactly you are migrating, the cloud version, configuration, copied where it's been stored. So Kolla Migrator will be taking the all of this migration, and Kolla Ansible is there to write to appropriate nodes where the migration would be done. So second step would be to copy and configure the Nova service in the container one. So once the complete successful copy and configuration for the Nova would be done with the Kolla Migrator, then we can start the Nova container on the migrated node. Once the service will start successfully there with the help of Kolla Migrator, if the Kolla Migrator does successfully for that, then that's the case, we will have the containerized cloud. And this is the whole thing we are doing for now on the same node, because just for the more easierness, so and get the one primary execution for this flow. So this is the this would be the more core things for the developing this tool and flow for the migration into the containerized from the non-containerized one. And this is the way of doing with the Kolla and for this, all the OpenStack services. So what possible steps and what possible configuration and data we would be first thinking to copy and to the target nodes itself. So if you talk about the networks node, so what setup has been done previously for the L3HA is been there, and it slave like Kolla slave, we have VRP restore cluster, and we have to stop the master node before migration, like I explained before, that we have to stop and to copy and configure the data. And L3 agent and all the agent service, we all have the images, so we know the where the data has been stored, what are the configuration are there. So these as we think for the network node configuration. And for the ironic one, you know that the copy of the PXE state we can mount as a volume to the ironic service into our new container, and we will copy the whole data for the ironic service in case of ironic migration. And for the Nova, we know that the Nova store is VM's data and volumes, libvirt and libvirt and uses, and we have to set the parameter for the C group for the containerized one in the Kuma itself before migration. And worst case with the for VM, like we do not want to stop the operation, so we have to do the live migration. And same we can see for the data plane service, Cinder and Swift, and some like in case of Swift we can see the container weight and rebalancing is there, but the data traffic can be the problem more. And Cinder for the we know that the existing one we use for the TGTD data for, and we have to copy that to the respective container of the Cinder in the Kolla one. And same with the glance images, we can just, in the case of that, it can be quite easy maybe to just copy and mount the appropriate volume in the container for the glance images. Now with the with the with the infra services, like what we can do with the DB and RabbitMQ. So within same DB version copy data to Docker volumes, it would be done. And worst case would be to take the backup, then restore it. And in case of Ceph already has done the same. We just need to go to the documentation of the Ceph for they already support non-containerized to containerized, and what they configure and they already support. So we just need to include those configuration and into the Kolla migrator tool. So this is the one of the things I tried to do with the Swift service, like what would be doing for the Swift. So you can see the we have the Swift cluster here, and account container and object service are running, and account DB is there, ring file might be there, we have, and we before migration we have to in case of Swift we do not need to stop maybe, because we have the Swift container, we just need to add that container to the Swift cluster as a new node. So this is the inbuilt property of the Swift we are going to use. At the same thing, we have to check for the other services too, that what the best case would be we can be using for the other services here. So this is the one of the case of the Swift service. We can see, like we just need to give the entry point of the new node, and we need to mount the data storage, and as we initially add the node to the Swift cluster, we add appropriate data storage point. So same would be with the container, and we just need to give the IP port for the new container to the Swift cluster, and we just fire the command from the Swift cluster itself to add node, maybe Swift at the level we can customize that as a add container. So what expected operation can be, and what we'll be doing with the Swift migration with the Kolla. Like we created an object in the non-containerized deployment, and we added container as a new node addition in the Swift, and then the object we have created, we will wait for the rebalancing itself. If the data is not large, then just need to wait, and you can again fire the request on the containerized service Swift to access the same object you have created in your old cloud. The challenges I faced to doing with my tool, like if the Swift has a very heavy data traffic, so that may be the case of copying. It will take very much long time, so it will be the very big concern for the in case of performance. So we just need to in that case we maybe we have to add as a container one, but not sure. I already checked with the Swift team, and they said that this is maybe not the case of adding to the single environment. You have to have the multi-cluster, and then you can rightly use for the migration one with the container. So I tried with the all-in-one installation and faced some of the issue. Like in the configuration, Swift has a ring file to configure the appropriate location where the object would be stored. So that things would be handled at the initial state when you are going to do with the Kolla migrator in with the ring file configuration itself to add to the Swift cluster. So these are the some of the challenges that newly need to be added to the Kolla migrator as well as some of the Swift side to support this kind of migration. So this is my experience doing the migration to the Kolla, the Swift service. And like I have done with the migration for the MongoDB for the I can show some live demo and code I have written for the tool I use for the migration one. You can see this is the architecture of the Kolla project, load balancing service and API, and MongoDB is used by the all the services for the storing the database so itself. So first of all, I as a initial POC and demo, I would like to show the migration of the DB cluster as a like we have the node. I can go to the actual node where the MongoDB actually is running. Yes. It's not, I think. Okay. This is the local terminal. Yes.
Oh, okay. So
yeah. This is the terminal.
can you get to your desktop?
Yes. Oh, I think I'm not.
Oh, the mouse is down here.
But not able to. So I think. I think it's not over.
Oh, okay. That's your desktop there. One sec.
It's not showing actually. Thanks. So here we have, I can first I would like, I looked at to show the operation I would be doing, like not working. Yes, I think already. Yes. So before doing, I would like to show the flow of doing the operations here in the demo. Like I have created, developed the tool for the Kolla migrator. This is the GitHub repo. You can see and check for, if you want to check for the same live demo and for the migration. So what actually Kolla migrator does is I developed for it polls the operation and apply the changes to the remote location or to the local host itself. So you can see with the go help run to for all the CLI available here with the Kolla migrator. And typically the command we will take the forward in the operation is like we have the operation with the will create the, like you can see here, yes, here is the your source one from where you would be migrating your the service, the application you is running, and the username that you would be using for the remote location access, and the password same, and we set the files for the SSL security group, and here the destination where would be your migration would happen, and the same with the username and the password we do. So this tool can be anywhere. So we provide the credential as per the source and the destination there to migration purpose. And here I have done with the testing for the Docker one. So I can show you some of the operation. Like initially you have the database of the MongoDB, and you can create that and credential, and you can apply the tool to you can create some of the data. Maybe yes, it's created. We have the some credential value here. You can see we are going to the same database to the destination node. Once Kolla migrator will apply the changes to the respective node. So we have the different node where the data would be copied, like into the containers. Because we have some of the Mongo images is here already, we can pull the latest one, and we can give the same configuration to the Kolla migrator tool to apply the changes. Some Docker login failure. Okay, I think I already have that one. Yes, we can apply. I think we are out of time already. Maybe we can check the ES1 data. So my main motive is to doing this, like we have created the database at the on the node, and you would be using the Kolla migrator tool, and you just need to go to the repo and run the give the source and source credential and the destination credential where you would like to migrate the application into the container one. There is some login issue. I think we are out of time. We can have the next question and answer session. Maybe already on. You all can check the repo and usage of the Kolla migrator tool for now for the MongoDB itself. And maybe next we can have the question answer all, as time had already so can we do we have any questions like do you all have any question? We can ask if you have any confusion anywhere. So here is the communication purpose. You can contact us on the Gmail or IRC. So I can help you out there to migration with the Kolla migrator tool. Maybe you can ping me on the IRC of the Kolla itself for this migration. Okay. Any questions, guys? No? Thanks.